Since the first spark of human ambition, we have been shackled by the invisible chains of friction and air resistance. For millennia, we fought to break the barriers of time and distance. Now, in this vast, silent expanse of desert, the world is about to witness the birth of the greatest leap in transportation since the invention of the wheel. We built the railroads, paved the highways, and defied the clouds with wings, yet we remained prisoners of classical physics. Every vehicle that came before paid a heavy energy tax just to push through the atmosphere we breathe. But what if we removed the primary enemy of speed? What if we could simulate the vacuum of deep space right here on the surface of the Earth? This is the mad genius of the Hyperloop, a world where resistance vanishes and speed becomes absolute. While our cities choke on congestion and smog, this project offers a radical promise, crossing hundreds of miles in mere minutes. This isn't just a train, it is a wingless spacecraft, flying silently through a vacuum-sealed steel artery. Yet, the true challenge lies not in the dream, but in the dirt. We are talking about a tube stretching across the horizon that must maintain a near-zero atmospheric pressure while surviving earthquakes and massive thermal expansion. A single mathematical error wouldn't just be a failure, it would be a catastrophe with the force of an explosion. The battle begins long before the first stone is laid. Geological survey teams use satellites and high-precision LIDAR to map the terrain down to the millimeter. The path must be as straight as a laser beam. At 1,000 kilometers per hour, a sharp turn would subject passengers to crushing G-forces. Beneath our boots, the soil hides dangerous secrets. Engineers extract deep core samples to analyze sand density and rock stability, desperate to know how every meter of Earth will react under the weight of thousands of tons of steel and concrete. The mathematics are staggering. Engineers don't just calculate distance, they calculate the literal curvature of the Earth. Over long stretches, the Hyperloop must be built to mimic the planet's arc. Otherwise, the tube would naturally rise off the ground as it moves forward. The schedule is a relentless master. The project requires a logistical symphony between thousands of workers, steel mills, and power companies. Every component must arrive at its precise minute. For even a minor delay costs millions. As the sun rises on day one, the giants wake up. A fleet of bulldozers and excavators begins to tear into the Earth. This isn't just digging, it's a surgical procedure on the planet to pave the way for the future of humanity. Natural obstacles are cleared with extreme precision. Every tree, every rock, and every waterway is accounted for. The goal is a surface as flat as a billiard table, stretching across continents. There is no room for human error. Satellite-guided lasers monitor the leveling, where the margin of error is thinner than a human hair over the span of a kilometer. Layers of gravel and compressed aggregate are laid down to act as a massive cushion, absorbing the Earth's natural vibrations to protect the sensitive tube that will rest above. The work never stops. Under the glare of massive floodlights, engineers review blueprints for the 1000th time. The next challenge is the deep foundations, the bones that will carry the weight of the Hyperloop. The land has been tamed, the canvas is ready, and now, the transition from sand to solid stone begins. The dream is over. The construction has started. The second phase begins with a violent rhythm. Piling rigs hammer the Earth with colossal force, driving steel and concrete pillars 50 meters deep. These anchors will hold the Hyperloop steady, preventing it from sinking or shifting. Massive steel cages, woven as intricately as a spider's web, are lowered into the dark shafts. This rebar will give the concrete its soul, allowing it to withstand unimaginable tension and pressure. The concrete used here is no ordinary mix. It's a high-strength chemical blend designed to resist soil erosion and groundwater for a century. It is poured slowly to ensure not a single air bubble weakens the structure. Workers use massive mechanical vibrators to force the concrete into every crevice. It must be a solid, artificial stone, impenetrable to a single drop of water. After days of curing, the pillar heads emerge like a disciplined army. Each point's location is verified with microscopic accuracy via GPS. Now, the giant molds for the vertical columns are assembled. Designed in a Y shape to distribute the weight of dual tubes coming and going, the design blends aesthetic beauty with structural efficiency. As cranes hoist steel skeletons weighing dozens of tons into the molds, the harmony between the operators and the ground crew looks like a high-stakes ballet. One wrong move is lethal. Giant pumps thrust liquid concrete to towering heights under immense pressure. Concrete is a living thing, sensitive to the elements. On freezing nights, the columns are wrapped and steam heated to control the chemical reaction. If it dries too fast, it cracks. Too slow, and the future is delayed. When the molds are finally stripped away, the concrete columns stand smooth as silk, and strong as armor. These will be the silent sentinels of the Hyperloop, standing tall against storms for decades. But the Earth is always moving. To protect the system from seismic shifts, advanced hydraulic dampers are installed atop each column. These allow the tube to glide and flex during a disaster, rather than snapping. Above the dampers, massive roller bearings are placed, allowing the metal to breathe, expanding and contracting as the desert temperature swings between the heat of noon and the chill of midnight. An endless line of concrete pillars now marches toward the horizon. The backbone is built. But while the concrete cures in the sun, another war is being fought in the factories. Special steel coils, forged from pressure-resistant alloys, are unfurled to begin the shaping of the massive tubes. Plasma cutters, burning hotter than the surface of the sun, slice through the steel with a surgeon's touch. Every edge must be perfect for the welding phase. The goal is a perfectly airtight vessel. Colossal rolling machines bend the thick steel, forcing the stubborn metal into its cylindrical form with the weight of hundreds of cars. Robotic welders take over, fusing molecules rather than just joining parts. The weld line must be stronger than the metal itself, incapable of leaking a single atom of air. We do not trust the naked eye. Every centimeter of the weld is inspected using X-rays and ultrasound. A microscopic gas bubble means the piece is rejected and melted down. At the ends of each tube, massive steel flanges are welded on. These are the connection points that will bolt the tubes together, designed to withstand the crushing force of high-torque bolts. The interior must be pristine. Sandblasting strips away every hint of rust or impurity, preparing the metal for specialized coatings that protect against corrosion and help maintain the vacuum. The tubes are painted a brilliant, reflective white to deflect the sun's heat. This isn't for looks. It's an engineering necessity to minimize thermal expansion that could warp the entire structure. Moving these steel monsters is a logistical nightmare. Specialized trucks with hundreds of wheels distribute the load to protect the roads, creeping through the night. In a solemn procession, police clear the way as engineers hold their breath at every bridge and turn. On site, the world's most powerful cranes lift the tubes as if they were feathers. The wind is a dangerous enemy here. A suspended tube acts like a massive sail. Ground crews and operators communicate via radio, where a small hand gesture translates into the movement of tons of steel. Slowly, the tube settles onto its bearings. When the tubes meet, the alignment must be laser perfect. There can be no lip or protrusion to obstruct the flying pod. Precision here is measured in microns, a staggering feat in a dusty desert. Hydraulic torque wrenches roar as they tighten the massive bolts. Every bolt's tension is recorded electronically to ensure even pressure and a permanent seal. Between the steel faces, advanced aerospace-grade rubber gaskets are placed the final line of defense against the atmosphere. Piece by piece, the silver artery grows, shining under the sun. The body is built, but the soul, the internal technology, is yet to come. We move now into the heart of the beast. Inside the dark metallic tunnel, the precision infrastructure begins. The environment is cramped, with a haunting echo. Aluminum and conductive alloy tracks are installed. These aren't rails for wheels. They are platforms for magnetic launch. They must be perfectly smooth. Robotic sleds crawl along the track, scanning with lasers for any deviation. Even a curve invisible to the eye could cause catastrophic vibrations at the speed of sound. Next come the linear induction motors, the muscles of the system. Instead of a rotating engine, the motor is flattened along the track. Complex copper coils will create the magnetic fields that propel the pod. Thousands of miles of wiring are integrated, each connection insulated for a vacuum environment where electricity behaves differently and more dangerously. Then comes the maglev technology. Powerful magnets or induction coils are mounted to lift the pod into the air, erasing mechanical friction entirely. Because the magnets and motors generate intense heat, a network of liquid cooling pipes runs alongside the tracks to keep temperatures within the safe zone. At regular intervals outside the tube, vacuum stations are built. Massive pumps, similar to those used in nuclear physics labs, work tirelessly to suck the air out. Huge hoses connect the pumps to the main artery, with giant valves designed to slam shut in milliseconds during an emergency. Safety is the ultimate priority. Pressure airlocks and emergency exits are integrated along the route. These small chambers act as lifeboats, allowing passengers to return to normal atmospheric pressure if a pod stalls. The inner walls are embedded with thousands of sensors: pressure, heat, vibration, and crack detection. This is the nervous system of the Hyperloop, sending terabytes of data to the command center. To maximize efficiency, the outer surface of the tube is covered in flexible solar panels, turning the scorching desert sun into the fuel for speed. substations are built to feed the power-hungry motors, with voltage regulated to ensure a smooth, stable acceleration. A high-speed fiber optic network runs parallel to the track, ensuring instant communication between the pod and mission control. Before operation, every speck of dust is removed. Autonomous cleaning robots sweep the interior because at the speed of sound, a grain of dust becomes a lethal projectile. Elsewhere, in sterile clean rooms, the vehicle itself is born, the pod. This is where aerospace engineering meets luxury travel in an environment resembling a NASA laboratory. The hull is crafted from reinforced carbon fiber light as a feather, strong as steel. Layers are hand-laid to ensure the best possible aerodynamics. The structure enters a massive autoclave, where heat and pressure fuse the materials into a single, cohesive masterpiece. Since the pod travels in a vacuum, it needs a completely independent life support system. Oxygen tanks and carbon dioxide scrubbers are integrated into the frame, just like in a submarine or a spacecraft. High-density batteries are placed at the bottom to lower the center of gravity. The magnetic levitation skids are attached parts that must interact with the track with zero physical contact. At the front of the pod sits a massive compressor fan. Its job is to swallow the tiny amount of air remaining in front of the vehicle and redirect it to the rear, preventing the buildup of air pressure that would otherwise choke the movement, a phenomenon known as the Kantrowitz limit. The interior is equally stunning, featuring shock-absorbing seats and digital displays showing virtual outdoor views, as real windows are impossible in a steel vacuum. A final pressure test is conducted, with smoke pumped around seals to ensure total isolation from the deadly environment outside. The pod is now a masterpiece of technology, ready to enter the speed tunnel and change travel forever. It is moved with extreme care into the airlock. In the control room, the tension is palpable. Systems engineers monitor hundreds of indicators. Everyone is waiting for the signal. The final phase begins with the big empty. The pumps roar at full capacity, and gauges show the atmospheric pressure dropping until it nears a total vacuum. The pressure falls to stratospheric levels. Inside the tube, there is no sound, no resistance, only a haunting silence. With the levitation system engaged, the pod silently rises a few centimeters. It has defeated gravity, floating on an invisible cushion of magnetic fields. The linear motors wake up. Electromagnetic waves surge, pushing the pod forward. The acceleration is initial and smooth, but the power behind it is immense. The movement begins. The tunnel lights blur. There is no wheel friction, no engine roar, only a ghost-like glide into the future. The numbers climb frantically. 100, 200, 300 kilometers per hour. In seconds, the pod has outpaced the world's fastest supercars. From the outside, there is nothing but a faint hum and a blur of silver. The beast is running in its cage. The pod glides over expansion joints. The engineering so precise that the transition is seamless. Inside the cabin, a cup of coffee doesn't even ripple. Engineers have successfully isolated the passengers from the violence of speed. 1,000 kilometers per hour. We are approaching the speed of sound. Thanks to the low pressure, there is no sonic boom to break, no shock waves to shatter the hull. Physics is finally on our side. As the destination nears, braking doesn't rely on friction, but on reversing the magnetic fields. The massive kinetic energy is absorbed and converted back into electricity, fed back into the grid. The vehicle slows gracefully and enters the station. The airlocks cycle, returning the pod to Earth's atmosphere. A journey that once took hours was completed in minutes. Passengers step out as if they have traveled through time. Distance is no longer a barrier. Distant cities are now just neighborhoods in one giant metropolis. This project is more than a way to get from A to B. It is a rewriting of global geography. Economy, tourism, and social life will change forever. We have folded the earth. Behind this achievement stands an army of minds, from the laborer in the desert to the physicist in the lab. The Hyperloop stands today as a testament to the human spirit's ability to defy the impossible. What was once science fiction is now a reality of steel and stone. This structure will stand for decades, perhaps centuries, reminding future generations that we did not accept our limits. We reached for the horizon. This is how the Hyperloop is built, an engineering miracle born of defiance, proving that our only limits are the ones we set for ourselves. The future isn't coming. The future is here.